This topic has been focused on proving congruent triangles. So we know that this word congruent means identical to. And what we want to have a look at today is what is the smallest amount of information that's required to prove that two triangles are completely identical? And how many of these proofs do we have available to us? Now, we have been studying these congruency proofs, and so far we should know that there are 4 that we've come up with. So we had SSS, which stood for side, side, side. We had SAS, which was 2 sides and the angle in between them. We had AAS, which was 2 angles and another side given to us. And our final test, which was a right angle triangle, the hypotenuse listed, and another side. Looking at those tests that are available to us, we can very clearly see that they all rely on 3 given pieces of information, and that there are 4 of them that are available to us. But looking at these 2 triangles here, there's lots of information that we can gather about them. We can match up 3 sets of sides that are equal to each other, as well as matching up 3 sets of angles that are equal to each other. So not only can we use these 3 tests to prove that these 2 triangles are congruent, but there is more information given to us as well. Is it enough that we could only use, say, 2 pieces of information to prove that these 2 triangles are identical? And that's what we're going to have a look at in this lesson. So let's start with the triangle below, and it shows all 3 angles. Is there any other way to make a triangle that has the same information, so that it has those 3 angles, that's not congruent to it? So think about it. If you have those 3 angles set, is there a way that I can redraw this triangle so that the angles stay the same, but the side lengths will be different? Okay, and it is possible. If I take this triangle and I resize it, looking at those angles, they are still exactly the same, but the side lengths are now much smaller. So again, if I want to, I can rotate this, I can resize this, and those angles are going to stay exactly the same size, but the side lengths will change. So knowing this, we know that we can actually make triangles that have the same information but different side lengths, meaning that they are not completely identical. They are similar but not identical to each other. So we can see from that just knowing the 3 angles in the triangle is not enough information. What about if we know all 3 sides? Is there any other way that I can construct a triangle with these 3 known side lengths that's different to the one that I already see and therefore not congruent? Now thinking about it, if I try to resize this shape, you can see very clearly that the side lengths are changing size, and so therefore I am not constructing a triangle with the same information that I started with. Now returning it back to its original size, what I can do with this shape is rotate it. If I rotate that shape, the side lengths are not changing. All I'm doing is translating it. But we know from our previous studies that this is still a congruent shape. I can turn, flip, mirror image, all of those things to my shape, and it is still congruent because I can match up matching side lengths and matching angles. So as we already know, yes, this is enough information for us to prove that those 2 triangles would be congruent. As we've already studied, this is our test side, 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 or SSS. Now we said before that there are 3 other congruency tests that are available to us. So let's have a look at those and see a little bit more about how they work. The next one we're going to have a look at is SAS. So we know that from our work that we've been doing, the angle that's been given to us must be the one that is in between the 2 sides given to us. And there is a reason for it. So let's have a look at why we have to have that given angle. Looking at the triangle below, we have two sides that are given to us, and we have an angle that is known to us, but it's not the angle that is in between those two given sides. From that information, is there another way that I can construct this triangle with a 6 centimeter side, a 4 centimeter side, and a 25-degree angle in this corner down here that is not identical to the one that's already been given to me? And the answer is yes, I can. If I take this 4 centimeter side, so the side opposite the angle that I've been given, and I rotate it, you can see that as you move it away, at the moment it's not forming a triangle, but looking very closely, it will hit a point where it matches up with that other side again. And therefore I can construct another triangle with these three pieces of information that is not identical to the one I was originally given. And this is exactly why we must have the angle between those two sides. If I set that 25 degrees between the two sides that are given to me, then I can't move this 4 centimeter side at all. It has to stay at that given angle. Putting it anywhere else in the triangle means I can move the side opposite and form another triangle completely different to the first one. So now let's have a look at our third test, which is angle, angle, side. We know in this test that we have to be given two of the angles, so let's take this one up here, we'll call it A, and let's take this one down here, we'll call it B, and we have to be given one of the side lengths. And it doesn't matter which side length's given to me as long as I know one of them. What I want to investigate here is why we need to be given this side length. As I said, it doesn't matter which side is given to me as long as I have one of them. The reason for that, if we know two of the angles in any given triangle, is it possible for us to actually find the size of the third one? Now, we already know from our previous studies that the angle sum of any given triangle is 180 degrees. So if I wanted to find that missing angle, if I've already been given the other two, and let's call this missing angle C, to find it, all I have to do is take away the sum of those two known angles from 180 degrees, and it will tell me the size of that missing angle. So really, in this test, by being given two of the angles, I'm actually aware of all three sizes. Now, as we saw at the very start of this lesson, by having only three sizes of angles given to us, that wasn't sufficient information to construct only congruent triangles from it. So the reason that we have to be given this other side length is so that the three angles will match, and keeping one of the side lengths constant means that your triangle cannot be resized, and therefore whatever you construct has to be congruent. This leads us to our next question, which is it enough to be able to prove that two triangles are congruent to each other if we're only given two pieces of information? As we saw, all the tests that we've used so far have relied on three. So let's try and construct two triangles that are congruent to each other with only two pieces of information. If we start with, let's say we have an angle, let's call that angle alpha, and we want that angle to be set at 30 degrees. And the other piece of information I'm going to be given is that the side next to that, so let's call it A, has to be 5 centimeters long. With just that given piece of information, how many triangles am I able to construct with that angle and that side length? And are all of them going to be identical to each other? So let's start with a 30-degree angle. And I'm going to set the side length next to it to be 5 centimeters long. Now there is no restriction on the length of the other side, on the other side of that angle. So that means that, yes, I could draw a triangle that looks like this and connect the other side up, and there's my triangle. Or I could start with that 5 centimeter length. I could set my angle to 30 degrees, but let's now make that other side length much longer. those two triangles still have the same information in them. They still match those two constraints that were given to us, but they are absolutely not identical to each other, which means that just having those two pieces of information is not enough to construct only congruent triangles, only identical triangles. The other one that we can test is if we know two side lengths. So let's say we want one of the sides, we'll keep it at 5 centimeters. And now let's set the other side, let's make it 4 centimeters. How many different triangles can we construct with those two pieces of information? So we've set the bottom side to be 5 centimeters, and now let's set the side that's next to that to be 4 centimeters. Okay, so that gives me one triangle, but knowing that I haven't put a constraint on any of the angles that are in this triangle, my 4 centimeter side doesn't have to go in this direction. I can put it anywhere and still make a triangle that follows those constraints. So if we set a 5 centimeter side to be the base, and this time I want my 4 centimeter side to go in this direction. Now my triangle still matches those two pieces of information at the start, but as we can see again, those two triangles are not congruent to each other. The last two pieces of information that we could test would be given two angles, but as we have seen before, if we're given two angles, then yes, we automatically know the third angle, and as we said right at the start of this lesson, knowing three angles and no other information is not enough to prove that two triangles are completely identical only. So the answer to this question is a big no. It is not possible to prove that two triangles are congruent to each other with only two pieces of information. So hence, what is the minimum number of conditions needed to prove congruent triangles? Well, as we've just seen, 2 is not enough to prove that they are identical. And what we need to make sure we have is 3 or more given pieces of information in order to prove that two triangles are and always will be, no matter how you draw them, identical to each other. So that means that the minimum number of conditions that we have to be given to prove that two triangles are identical will be 3. And in how many ways can we prove that two triangles are congruent to each other? Well, as we've seen, our 4 tests are all involving those 3 minimum pieces of information. So that tells me that there are 4 different ways to do this. And again, as we have seen, just to recap, those 4 tests are proving that the 3 sides are congruent to each other, which means that all 3 sides must be given to us, and therefore those 3 minimum pieces of information are available. We can have side angle side with the angle included between those two given sides, must be the angle between those two given sides. We can have 2 angles and another side, which, as we have seen before, this actually gives us 4 pieces of information, but we are only required to prove 3. And the last one is being given a right angle triangle, being given the hypotenuse length. Remember, that's very important. If we're not given the hypotenuse length, the test that it confirms is actually side angle side, because the right angle will be between the two given sides. So RHS relies on the hypotenuse and another given side, and again following those 3 minimum pieces of information.